Hello everyone, welcome back to this channel. This video is part of a playlist that aims to take a look at networking protocols through the help of devices that are readily available, such as the ESP32 and Raspberry Pi. This video is a continuation to our last one, which we took a look at Bluetooth Low Energy, or BLE, and examined its working principle. This video, we will implement what we have learned so far through the use of an ESP32 device in a simple sketch. The video will be split into three main sections. We will first recap what we learned so far in our last video about the Bluetooth Low Energy and its BLE stack. Then we will take a look at the plan of action for how we will implement what we've learned. And finally, we will take a look at the implementation. In this video, we will need the following tools. We will need an ESP32 board, your laptop with the Arduino IDE installed, and a smartphone. Bluetooth Low Energy, or BLE for short, is the power-conserving variant of Bluetooth. As we've seen in our last video, BLE uses the generic attribute profile to define the way that two BLE devices transfer data back and forth. And GAT does that through a hierarchy. The top level of the hierarchy is a profile, which is composed of one or more services. Usually, a BLE device contains more than one service, and every service contains at least one characteristics, which is the attributes that make up the sensor readings, for example. There are predefined services for several types of data defined by the Bluetooth Special Interest Group, like the battery level, blood pressure, and heart rate readings. Each service is made up of a characteristic, and a characteristic is where the actual data is contained, and the characteristic is made up of the attributes included in the service. It's important to note that each service and characteristic have a UUID, or Universally Unique Identifier. A UUID is 16 bits long if it's predefined by Bluetooth SIG, or 128 bits long if it was custom made. Characteristics contain the data value, the descriptor, and some properties, where these properties indicate to the client connecting to the BLE server which operations are allowed to be performed on this characteristic. And it can either be a broadcast property, a readable property, a writable property, or a notifiable property. And these are the four most common properties for characteristics within the generic attribute profile. If you'd like to learn more, you can check out our last video where we have gone through this in detail. In this video, we will create a BLE server using the ESP32 and connect to it through our smartphone with the help of an application known as NRF Connect. To do so, we will need to follow the following steps. In this video, we will be creating a BLE server. And in that server, we will create a service. And for that service, we will create a BLE characteristic. And then for that characteristic, we will create the descriptor. We will start that service, start advertising, and try to connect to this BLE server that we've just created through our phone, which will act as a client. To do that and to connect to this BLE server that we will be creating through a simple sketch, we would need a free application called the NRF Connect for Mobile, and it's from Nordic. You can find this application for Android on Google Play or in the App Store for iOS. Now let's take a look at the sketch. To find the sketch, navigate over to Files, Examples, BLE, and click on Server. To find this sketch, you must have ESP32 selected in your boards over here. And you must have the ESP32 library installed onto your Arduino IDE. Now let's take a look at this code. First and foremost, we must import the necessary libraries for the BLE capabilities. Then, as we've mentioned, each service and characteristic has a UUID. And so this sketch uses these UUIDs. You can go ahead and make your own UUID through the uuidgenerator.net. And you can use this to create your own UUID, but I will go ahead and use the default UUIDs. Then when we go to the setup loop, we can see that we first start by initializing the baud rate for the serial communication. We then create our BLE device. You can either keep the name as long name works now, or you can change it, as I will, into BLE test server. And this is the name that will appear when scanning for BLE devices using our phone and the application we just mentioned. We then create the server using BLE device create server. We then make sure that when we have created the server, we create the service within the server using the service UUID that we have defined over here. Then for this service, we need to define a characteristic. And so we have used the characteristic UUID over here, and we have enabled the property read and write for that characteristic. We can set a value over here for this characteristic, and I will go and set this to this is a test implementation. And we will have to see this message when we flash the ESP32 and start scanning for the device that we've just defined over here. After setting the value of the characteristic, we can start the service and then start advertising for that service so that other BLE devices can scan and find the device. Now let's go ahead and flash our ESP32 device. We must make sure that we have chosen the appropriate COM port and the appropriate board. Let's wait for it to compile, and once we flash our ESP32 device, we can open up our serial monitor. Let's wait for it to flash. And then we can go ahead and open up our serial monitor. See that it's starting to work. The BLE device is starting to work, and we can read it in our phone. So let's go ahead and open our phone, most specifically the NRF Connect application, and see what we can observe. First and foremost, we need to open our application and try scanning. And as you can see, the first thing that we can see is the BLE test server that we've created. When we go ahead and open it and take a look at the advertised service, we will notice that the UUID is exactly as the one that we've defined in our code. And when we go ahead and connect, we can see that this service, which is an unknown service, and it's the primary service, has an unknown characteristic with a UUID that is similar to that we have specified in the code. We can also see that the properties are read and write just as we've specified in our code. When clicking on the down arrow, we can see that the value is in a format that we could not understand. So let's click on the double quotation and change the data parser from byte array to UTF-8. And we can see that the value that we've defined for our characteristic is just as that in the code. And with that, we have successfully connected to our BLE device, which is the BLE server that is our ESP32. And we have observed the UUID for both the service and the characteristic, as well as the property for that characteristic and the value of that characteristic. I hope you found this video useful, and if you have, consider subscribing or supporting the channel through Patreon, where the link for that is in the description below. You will also find a Medium article where this tutorial will be in article format, and it will contain snippets of the code as well as some explanations for the code. And as always, thank you for watching.